Exploring Mars sounds simple. Send a rover, drive around, collect rocks. In reality, it's one of the most complicated robotics problems ever attempted. NASA's Perseverance Rover landed on Mars in February 2021 inside Jezero Crater, an ancient river delta scientists believe may once have contained water. The rover's mission is to search for signs of ancient microbial life and collect samples that future missions may return to Earth. But operating a robot on another planet introduces a fundamental challenge: distance. Mars sits tens of millions of miles away from Earth. Radio signals travel at the speed of light, but even that speed creates delays between 5 and 20 minutes depending on planetary alignment. That means real-time control is impossible. Engineers cannot steer the rover like a remote control car. By the time a command reaches Mars and the response returns, nearly half an hour could pass. Perseverance must drive itself. The rover uses autonomous navigation systems built around stereo cameras and onboard computing. Cameras scan the terrain, software analyzes obstacles, and the rover selects safe paths forward without waiting for instructions from Earth. Autonomy isn't optional, it's required for survival. Then there's the environment. Mars may look calm from orbit, but conditions are harsh. Surface temperatures can drop below minus 100 degrees Fahrenheit, approximately minus 73 degrees Celsius. Dust storms can cover the planet and coat solar panels or instruments. Perseverance avoids solar power entirely. Instead, it runs on a radioisotope thermoelectric generator, or RTG. This device converts heat from decaying plutonium into electricity, providing continuous power regardless of weather or daylight. That power supports a mobile laboratory. Perseverance carries advanced scientific instruments designed to analyze rocks and soil. Some instruments use lasers to vaporize small portions of rock, allowing spectrometers to determine chemical composition. Others search for organic molecules that could indicate past microbial life. But one of the rover's most important tasks is sample collection. Perseverance drills into Martian rock and seals the samples inside special titanium tubes. These tubes are left on the surface for a future mission that could retrieve them and return them to Earth. This would allow scientists to analyze Martian material with far more advanced instruments than any rover could carry. Another remarkable piece of technology associated with Perseverance is Ingenuity, the small helicopter that accompanied the rover. Although Ingenuity was a separate system, its success demonstrated powered flight on another planet. Flying on Mars is difficult because the atmosphere is extremely thin, only about 1% as dense as Earth's. That means rotor blades must spin far faster to generate lift. Back on the ground, Perseverance continues its exploration. Its aluminum wheels must survive sharp rocks and rugged terrain. Its electronics must function through temperature extremes. Its software must guide the rover safely through landscapes humans have never walked. Every day, the rover performs a delicate dance between autonomy and remote guidance. Engineers on Earth plan routes and scientific targets, but the rover decides how to reach them safely. In many ways, Perseverance represents humanity's robotic extension into space. A machine acting on our behalf in a world we cannot yet visit ourselves. And every meter it travels across Mars brings us closer to answering a profound question. Was life ever there?